Every time we look at an airplane, we notice the massive engines, the giant wings, or the advanced cockpit. But almost no one pays attention to one of the most important parts of the entire aircraft, the tires. Here's something incredible. A passenger jet weighing hundreds of tons can touch down at speeds of over 250 kilometers per hour, and for the first few seconds after landing, almost all of that force is absorbed by the wheels. So why don't airplane tires explode under that pressure? Why are they filled with nitrogen instead of ordinary air? And how can a single set of tires safely stop an aircraft weighing hundreds of tons? Today, we are taking a closer look at one of aviation's most overlooked engineering marvels. When most people think about an airplane, they picture its powerful engines, enormous wings, or the sophisticated technology inside the cockpit. But one of the most important parts of the aircraft often goes unnoticed: the landing gear and its tires. Ironically, the most demanding moment of every flight happens during landing, when these tires take the full impact of an aircraft weighing hundreds of tons. A large passenger jet can touch down at speeds exceeding 250 kilometers per hour. Within just a few seconds, its tires must absorb an enormous amount of force while maintaining stability and control. There is absolutely no room for error. Every aircraft tire is engineered to withstand extreme weight, intense heat, and sudden changes in speed. These are far more than oversized rubber tires. They are highly tested, safety-critical components that are continuously inspected throughout their service life. If there's one part of an airplane that simply cannot afford to fail during landing, it's the landing gear. Once you understand how these tires work, you'll never look at an airplane the same way again. This raises an interesting question. If aircraft tires are so important, why aren't they filled with ordinary air? What exactly is inside them, and why? The real challenge begins the moment the aircraft touches the runway. Before touchdown, the wheels are not spinning. But the instant they make contact with the ground, they accelerate from 0 to more than 200 kilometers per hour in just a fraction of a second. That sudden acceleration creates tremendous friction, which is why you often see brief puffs of white smoke during landing. But speed is only part of the challenge. A fully loaded passenger aircraft can weigh anywhere from 300 to 400 tons, and all of that weight is transferred onto the landing gear within seconds. At the same time, the aircraft must slow down rapidly without losing stability. That's why every component of the landing gear is designed to absorb enormous forces without bending, breaking, or compromising the aircraft's balance. Naturally, many people wonder how airplane tires survive such extreme conditions without bursting. The answer lies in their construction. Aircraft tires are completely different from car tires. Instead of a simple rubber structure, they contain multiple layers of high-strength synthetic materials such as industrial nylon and aramid fibers. These reinforced layers create an incredibly strong structure that resists deformation even under immense pressure. This isn't just rubber, it's a remarkable example of precision engineering. Another major difference is tire pressure. A typical car tire operates at around 30 to 35 psi. An airliner tire, however, is typically inflated to about 200 psi, roughly 6 times higher. That extremely high pressure allows the tire to support enormous loads while maintaining its shape during landing. Before entering service, aircraft tires undergo rigorous testing, including high-speed landing simulations, maximum load tests, and durability inspections. Because in aviation, even the smallest mistake is unacceptable. Now here's something many people don't know. Aircraft tires aren't filled with ordinary air. Instead, they're filled with dry nitrogen. This isn't a marketing gimmick, it's a critical safety measure. The air we breathe contains oxygen and moisture. During landing, heavy braking generates tremendous heat. If oxygen and water vapor were trapped inside the tire, pressure changes would become less predictable, increasing the risk of overheating and internal damage. Nitrogen solves that problem. It's an inert gas, meaning it doesn't react easily with other materials. It's also completely dry, preventing internal corrosion and making pressure changes much more stable as temperatures rise. That's why nitrogen has become the aviation industry standard. Now let's answer another interesting question. Why do large airplanes have so many wheels? Take the Boeing 747, for example. It has 18 wheels. The Antonov Ant-125, the world's largest cargo aircraft, had 32. This is unfortunately essential. A massive aircraft landing with hundreds of tons of weight would place enormous stress on the runway if that weight were concentrated on only a few tires. By distributing the load across many wheels, engineers reduce pressure on each tire while also protecting the runway surface. More wheels also improve stability during landing, braking, and taxiing. But what happens if one tire fails during landing? Aircraft are designed with redundancy in mind. No single tire carries the entire load. If one tire becomes damaged, the remaining tires are capable of supporting the aircraft safely. Unlike car tires, aircraft tires are also engineered to lose pressure gradually rather than fail catastrophically. There have been numerous cases where aircraft landed safely despite one or more damaged tires because the entire landing gear system is designed with multiple layers of backup protection. Safety in aviation is built on engineering, not luck. The wheels also play a major role in stopping the aircraft. Large passenger jets use powerful carbon brakes capable of operating at temperatures exceeding 1000 degrees Celsius. Stopping hundreds of tons of moving aircraft requires absorbing an extraordinary amount of energy. But the brakes don't work alone. Immediately after landing, spoilers deploy on top of the wings to reduce lift, transferring more weight onto the wheels and making braking more effective. At the same time, thrust reversers redirect engine power forward, helping slow the aircraft even faster. It's a perfectly coordinated system where the landing gear, brakes, wings, and engines work together to bring a massive airplane safely to a stop. Finally, there's maintenance. Aircraft tires are expensive, often costing several $1,000s each depending on the aircraft type. However, replacing them after every flight would be incredibly wasteful. Instead, many aircraft tires are retreated several times. The one rubber tread is replaced while the strong internal structure is carefully inspected and reused, provided it still meets strict aviation safety standards. Every tire is monitored throughout its service life. Engineers keep detailed records of every landing, every inspection, and every sign of wear. So while airplane tires may seem like small components compared to the rest of the aircraft, they are among the most carefully engineered, thoroughly tested, and closely monitored parts on the entire airplane. Every safe landing depends on them. If you enjoyed this video, don't forget to like, subscribe, and let us know in the comments what aviation topic you'd like us to cover next.